And we are back. We have Adam and help us. Platform engineers must change developers and database, and his how. So Adam, take the stage and please teach us how to do it.
Cool. Thank you so much. And hello, everyone. Thank you for coming to this talk. My name is Adam Furmanek, and I'm a head of DevRel at Metis, where we work with databases. And today, for the next some minutes, we are going to discuss how to improve the state of the databases. We are going to see how platform engineers should reshape the world today to make it better and more adjusted and more tuned to the modern DevOps. We are going to see that while we learned a lot when it comes to DevOps and software development lifecycle, there are still pieces that we are completely missing and lacking when it comes to automating our pipelines, reasoning about our systems, and generally doing the work efficiently. So the plan for today is just to understand what we miss, what to build, and how platform engineers can reshape the world. So let's jump straight to it. So we are going to go through a couple of ideas. First, we are going to understand what is the current state of SDLC and why Conway's law is still like very painful for our organizations. Then we are going to briefly take a look at what breaks today, especially in DevOps databases and throughout our pipelines. And then we are going to see what we need and how to do it. Let's go. So the very first thing is we need to realize that we finished, or we actually moved through a significant transformation over the last years. So 10 years ago or 15 years ago, whenever we were working on applications, it was generally rather straightforward. We had like monolithical applications. When there was an app, there was just one database, maybe a couple of like nodes for load balancing, and generally a user touching that. Whenever we had to change something, we were generally modifying this single application. And when something broke, it was rather straightforward to understand where to look for the issues and where to look for the answers, what could go wrong. In very rare cases, we decided, okay, let's build a completely independent application on the side. It was a big thing for us. We didn't want to build something completely new because, well, deploying and generally starting from scratch was super expensive and super slow. And we learned that that might not be the best case. What we learned and what we did over the years is we moved from that very simple world to much more complex one, a world where we have multiple databases, be it SQL, NoSQL, vector databases, things for machine learning. We have various ways of hosting our code. We have serverless solutions, we have Kubernetes, we have on-prem, we have cloud, and many other things. And most importantly is all those elements, they talk to each other. This is the hardest part about what we need to deal with today. It's not only that we have plenty more elements, but also they constantly chat with each other. And when there is a problem, we do not necessarily know how to debug it. It might be that our database is slow, but it's not the database what is the issue. It might be that our application is crashing, but we can't find anything about that in the logs of the application because it's due to some other microservice or the traffic that comes to application. Looking for logs, looking for traces and all the signals around is way harder now than it has ever been before. And this generally is like a good sign for us because it means that yes, we learned how to tame this whole complexity, how to develop things fast, how to deploy them more often, many times a day, and how to generally keep all that ecosystem under our control. The problem is though that we completely left out databases. We do not cover them in our landscape, and we are going to see in this talk why that's the case, why our CI/CD pipelines do not cover the problems we have with databases, and how to change that, how to let developers own their databases the same way they own their applications, no matter whether they are small startup or Fortune 500 enterprise, no matter how long they are in the market. This is something they need to do today. The world has changed, and the problem is we moved from doing things manually to doing things in this automated way with GitOps, with infrastructure as code, with anything as code, but we are still running in silos. Yes, the DevOps idea was that we realized, okay, development team and operations team, they need to be much closer together. So initially we wanted to put them like side by side, and ultimately we kind of blended them together. So now we have just one team responsible for both development and operations. The problem is this one single team does not tackle everything that is important to successfully deliver the software. Nowadays, it's a big thing for us to have DevSecOps. We try to mix in the security principles into this DevOps world, but databases are still outside. And if we take a look at how the world looks like, we often realize that, hey, on the left side on the screen, what we see is like how we describe our applications. There is a client of our APIs that talk to a data store. But if we bend this image 90 degrees, then we realize we are actually hitting the silos. We have one team responsible for like development of the application or the client, another team responsible for building the APIs, and very often yet another team or separate like group of people responsible for working on the databases. And if we take a look at that, we may realize that in turn, this is actually Conway's law in its essence. Conway's law is telling us that the applications we build will closely resemble the organization, the structure of our organization, our org chart. And we still see that. If we have DBOps or if we have data like DBAs sitting somewhere else in different room, then we will have a separate layer for the database and we will have those silos. Actually, there are even research done showing that if some other team is further away than like 20 meters from where you sit, then you are most likely running into silos and your performance will drop. This is the empiria, something we can measure in the real world. So moving on, the problem with this approach that we have is when we have those separate teams, the communication increases. And we can draw fancy org charts showing us that this team talks to that team, yada, yada. But the reality shows that the talk is what actually structures the organizations. So no matter how we are sitting like between the teams or what silos we try to form within our organization, the actual paths that we should follow is the communication paths. And this may show us where we have those silos and how to deal with them. And in order to deal with them, we need to understand that in order to automate everything, in order to make our DevOps run faster, increase velocity and improvement of the stuff, we need to shift everything to the left. That is the most important idea for all the automation. We need to shift to the left, move to the early stages of the pipeline, everything that may slow us down. This includes testing, load testing, security, databases, like configuration, deployment, and other stuff. And we are going to see that through this talk to understand what we need to bring into the left to make things faster. And the other super important part to running DevOps successfully is self-servicing everything. We need to let developers own their stuff and self-service their issues. That's the important part, because we can't let them or expect them to talk to other teams because communication is slow. We can't force them to raise issues in Jira, tickets, or whatever else, because this is what slows them down. So we need to shift everything to the left and make them self-service their issues. This is what we need to do. And we may say, okay, but developers should be able to do it right away, right? They own the infrastructure. DevOps engineers own the infrastructure. They can deploy stuff. They can build their applications, test them. They can even see all the monitoring around, right? So they should be able to do it. But is it really the case? And let's see that it's not. First thing about monitoring is that whenever we talk about monitoring stuff, we typically think about dashboards like we see on the screen. And they all look great. They show you metrics, charts, diagrams, whatever you like. The biggest issue with those metrics is that they do not give you the answer what to do. and where the problem is. They only show you that, hey, your CPU spiked somewhere there is fire burning out there, and that's all you know. You have no idea what's the cause, you have no idea how to fix it, and more often you are swamped with tons of metrics that you have no idea how to act upon. Like those monitoring solutions, they very often boast that they can bring hundreds and thousands of infrastructure metrics automatically. They can get OS metrics, runtime metrics, CPU metrics, memory, etc., etc. But in reality, that's not what we need. We don't need to go for quantity. We need to go towards the actionable answers, what to do. And monitoring solutions do not give us that. So let's try to understand what we need to build in order to actually give our developers those actionable insights. And in order to do that, we need to understand what actually can break today and what are those blind spots, those gaps that our developers miss. So whenever we talk about databases, we can all typically we can group problems in those three areas. So the first area is code changes. So those are problems that we changed our application code. We in turn changed the SQL query that has been sent. We changed how the things are executed. And no surprise, things are now going way slower. Okay, this is the first area. And this is the area that we pretty often try to cover with unit tests. Obviously, we changed the SQL query, so we try to run tests that will tell us whether we are reading and writing the proper data. The other area is schema changes. So we change the database schema, we add columns, we change the data types and do whatever else. And this may obviously change the performance of our application because our ORMs may go crazy or whatever else. So we try to cover that things to some extent by testing those schema migrations like in our local environment. We just run them. But very often, we do not have any idea how long such a schema migration may take in production. When we run schema migrations locally, we have 100 rows in our database. Those schema migrations will complete very fast. But once we go to the production, it may be that the schema migration will complete in minutes or even hours. And this typically takes our database down and causes an outage. There are always, or sometimes there are even cases when a schema migration may take days or weeks to complete. We know some of the protocols, how to deal with that, how to drop columns safely and in a way that we do not break things. So we rename those columns and we drop them only a fiscal year after we regenerate everything, so we are sure no software has been impacted. But generally, those things, they are still tricky. But there is yet another area where we have no idea what to do, and we do not cover that in our DevOps pipelines. And this area is query changes. And I'm not talking about the way that we changed our SQL text. No, I am talking about the situation when our query slowly degrades and basically rots over time because our configuration changes, our indexes change, our Windows or Linux or operating system updates change. And we generally have a query that used to work very fast, but now 6 months after, some index has been dropped or modified, and the query changes the execution plan. So the query still works, still gets the data, but does not do it in a way that it used to do it before. So it changes the performance and effectively is too slow in our production case. Those are the things that we do not cover in our CI/CD pipeline at all, and our DevOps engineers, they do not see what's going on. Let's see a couple of examples. Imagine that we have an application code like here on the left side. So we basically have some JavaScript code that actually comes from one of my production systems. We basically want to get a user, and what happens is we get this user. We want to join many tables to bring the data and ultimately build just one single aggregate that would represent this object, right? And in turn, this code produces query on the right-hand side. So we see that a select statement with like many left joins. And if we run things like this in production, then this runs for 25 seconds and extracts something like 300,000 rows from the database. Why that's the case? That is because when we have like this many joins, we increase the number of rows exponentially. So in turn, what is going on? The database needs to produce so much data, then it takes like nearly half a minute for the ORM to process and build this one single entity. What is the solution to this problem? At least in this case, the solution was to basically drop the case of like taking all the data in one go and extracting those things like separately. So this leads to many SQL statements being executed. And one might say, okay, those SQL statements should be slower because we send something like what, 8 queries instead of 1. But the reality is those statements are super fast and they bring much less data. And the important part here to notice is that unit tests for both of those cases, for this query and for this set of queries, those unit tests will be green in both cases. Why is that the case? That is because we only focus on whether we extract the correct data, whether we read the data properly, and whether we build the entity that we build at the very end is the same, is correct. And those unit tests will cover those cases the same way. They both will be green. The problem is one scenario will be fast, but the other will be way slower. And our tests won't notice any difference. Yet another thing is developers may be tempted to like rewrite the code to make it more readable. So let's say that we have like a query that tries to extract things from boarding passes, and we have something like 8 million rows, and we basically want to get the ticket number and calculate like double hash of this ticket number, right? So we calculate MD5 twice. And you may say, okay, we build this query, we join like the table 3 times, and then we need to repeat or duplicate the code to basically calculate this double hash like 3 times, as we can see in this code. So how about we just use common table expression, CTE, that basically calculates this ticket number hash once, and CTE is just a conceptual temporal table, so it shouldn't affect the performance, and effectively we end up with much more readable query that we do not duplicate the logic. The problem is, though, that the first query runs in 8 seconds, and the other query that is now more readable finishes in 13, so nearly twice as long. So just by making the code more readable, we effectively decrease the performance significantly. And once again, the tests or the CI/CD pipelines that we have, they won't notice this problem because they focus on the correctness of the data, not on the performance. You might say, okay, we might have load tests that will cover that. We'll get to load tests in a second, but let's for now realize that we don't capture problems early in our stages. So whenever we talk about tests, whether it's unit tests, integration tests, end-to-end tests, there are so many things that may break, and our tests won't capture that because the pyramid of tests is simply not covering those things. But you may say, okay, load tests. Load tests should cover that, right? And you would be right in here. Load tests would cover that. But there are problems with load tests. First, they are very slow to complete. They literally take hours to complete. Not to mention that it's hard to build them because we need to anonymize the data, deal with GDPR, California Protection Act, and other stuff. Not to mention they are expensive. We need to build a separate stack on the side to run the load tests and do the magic, pay for those machines. And if it involves like machine learning, then we need to pay for crazy expensive GPU-enabled machines. But the biggest issue with load tests is that they happen nearly at the very end of the pipeline. So they happen far too late. You already implemented your changes, merged the code into the repository, reviewed it with your teammates, deployed it to non-production environments, and only then do you realize that there is a performance issue. And that is the problem. Load tests, they conceptually work. They are hard to build, expensive to maintain and run, but they are way too late in the pipeline, and this is what kills our performance. We need something better. So let's see what we need. And solution is database guardrails. So we need something that will let developers to own their databases end to end, and they need something, developers need something that will show them that there are problems, and it will show them those problems early in the pipeline. It will let them diagnose those problems and reason about the performance of the database. Developers often lack understanding of databases just because they are scared or maybe not used to that. However, we must let them own their databases end to end. And the key part here is we wanted to let them own more, but do less. That is the idea. They need to own bigger scope, but do less work. And let's see how database guardrails can do that. So database guardrails focus on a couple things. First thing is understanding what's going on with the databases and giving actionable insights. So just like we had telemetry early, like a couple years back. So basically we had this ability to collect logs, traces, metrics, whatever signals from our applications. When we integrate telemetry throughout our ecosystem, we have something that is called visibility. So we can clearly say, okay, we can look into each aspect of our system and basically see what's going on there, thanks to telemetry. We can use that to build the APM, application performance management. So we can say whether our application is green, ecosystem is green, or if there are problems or performance issues. But we need to take it a step further. We need to build the proper observability that tells us what is going on. So the difference between monitoring and observability is monitoring focuses on the raw signals, on swamping us with data, on the metrics, on alarms, on things that we need to tune manually and basically adapt them to our cases. Observability, on the other hand, gives us actionable understanding of what's going on, explains that we deployed this stuff and this is how it affects this whole ecosystem. Observability captures the data throughout the SDLC, starting from the developer's environments, throughout the CI/CD pipelines, and with the production environment at the very end. So the modern observability we need to build should look like this. So we basically start with our developers writing some code. They do that in their local environments and they run their applications locally. What we do next is we capture everything with like telemetry, open telemetry, whatever else, and we capture how this application interacts with the database. And we can then deliver that to a platform that will be able to reason about what's going on. Similarly, we do the same for our CI/CD pipelines. We run the things, we capture them with the collector and deploy to the pipeline. And now comes the tricky and the crucial part. We want to do the same with our production database. So we want to capture the interaction between like applications and the production database and also see what's going on. What does this give us? This lets us to do the projection. So what we can do is we can take the application running locally and how it talks to the database, and then we can project that onto the production database to analyze whether the queries, schema migrations, and whatever other stuff that we run locally here at this point, whether it's going to be fast enough when we run it against production. So this way, we can reason about what's going on early in the pipeline and tell our developers immediately that their solutions won't scale well or won't work fast enough. So this is the very first part we want to do. We want to bring the tools to the developers so they can reason about the performance early in the pipeline. But the other thingy that we need to do is we want to capture the thingies throughout our collectors, and understand how these things, how they move from the local environment to production throughout CI/CD. So we can understand what is being changed when it comes to schema, configurations, indexes, extensions, and all the other stuff, and how those things change throughout the pipeline. So this way, we can provide a full-blown end-to-end observability that gives actionable answers explaining that, hey, your production is now being slow because you deployed this thingy and it affected the production ecosystem in this way. So this is the idea with modern observability. So the first part we need to do, and the first part we need to provide to developers, is the prevention part. We would like to project the query onto the production, integrate with developers' IDEs, their environments, and analyze how those queries execute. And in order to do that, we need to build the observability in the developers' environments and also in CI/CD pipelines. We want to analyze those things as like a way of doing automated code reviews for our developers. So this way, they can not only test their code with like unit tests that will focus on whether we read and write the proper data, but they will also get insights like, okay, your query works well when you run it in local environment because you have what, 100 rows in your database? But the moment you go to production where you have like 1 million of rows, your query is going to be way too slow. You need to change it. And this is how you change it, because we know how the query is going to execute in production, because we projected it in the production and extracted the execution plan, and we can even fix the code automatically by submitting pull requests or giving like hints in the IDEs. And the other part we need to do is we need to build the observability that analyzes how things evolve over time, how our indexes change, how our configurations change, how operating systems change our ecosystem. And we can do that. We can correlate the deployments with production changes. We can correlate infrastructure as code. We can correlate GitOps and other stuff. We can monitor database-specific oriented metrics that will show things like transactions, execution plans, etc., and visualize all of that and connect the dots. And once we have that, we can give our developers answers what to do and how to do it. So this is how database guardrails work. They prevent the bad code from reaching production. They monitor the system end to end and turn raw data, raw telemetry into the actual observable knowledge and actionable insights. And they can even automate the stuff. They can troubleshoot things automatically and give you things that you can just run. So this is what it comes to tooling. But the other part we need to do, and this is where platform engineers really need to shine, we need to change the processes. We need to reorganize how our developers work. We need to be proactive and push all the things to the left as early as possible. Our teams are slow because they lack permissions. They can't access logs. They do not have knowledge about databases. They need to attend office hours to get help from other teams. They need to get explicit approvals, and they cannot self-serve their issues. That is the most important part. We need to change the mindset of the databases, of the developers, cut the communication, stop them from raising tickets, but instead own the databases and reason about them on their own so they can work within their teams much faster. We need to build the knowledge and understanding to give them this way to reason about everything in the databases, no matter whether it's like trivial stuff or some low-level internals of the databases, so they can understand and realize that they are like now the owners, and they can feel confident enough to reason about databases. And finally, we need to let them self-serve their issues. So when there are problems with the databases or whatever, it must be them who tackles those issues, not some DBAs, not some other teams, but developers. And database guardrails is all about the mindset that developers can own their software including all the parts of the software end to end, from the very beginning to the very end. And we need to build this mindset. They can own their databases, and it's not about giving them more things to do. It's about letting them own more, but making them do less work. It's about replacing their communication with other teams, raising tickets, asking for permissions, with things like getting actionable insights and getting true answers to what is going on. It's about replacing part of their work with some other work that can be done much faster. In summary, databases may break in so many ways. There are issues around like how queries execute, around schema changes, schema migrations, around ORMs and other stuff. And we need to be proactive about that. We can't wait for the load test to complete. We need to push all these things to the left and be as fast as possible. And we need to finally give the developers the database guardrails, tooling for actionable insights and understanding what's going on, the understanding of all the internals, and finally change their mindset so they are owners and they don't need to ask for permissions and communicate with other teams, but they can own everything end to end. And not to mention there are tools like that. Metis, where I work, is one of those. So I encourage you to take a look at what we built if you like this idea. And being all of that said, it's time for Q&A. So if there are any questions, I am happy to take them now. Okay, cool. I don't see any questions out there. Maybe if there are, then feel free to let me know.
Thank you, Adam. Yeah, so that was a nice presentation, very insightful. Do you see
Thank you so much.
anything that can be still right shift, that is hard to be left shift?
Well, generally, I don't think we will be able to do this like light shift movement or left shift movement like in one step. After all, at the very end of the day, we always deal with the live data, right? This is the data, our customers' most precious stuff that we can never break. So automating fixes, like automatically changing the code or tuning the configuration, is probably something that we will be hesitant to do at this point. We may get like actionable insights, so the database guardrails will show us, hey, this is what you need to fix, but database guardrails will not fix that on their own just because we will be too scared to do so. So I think this is something that will still be kind of a right shift instead of left shift, if we use this wording. And this is something we will get to probably over longer time. But the point here is, it's not gonna be, and we shouldn't expect that it's like one step and bang, all is solved. No, it's gonna be a journey, and we will need to take many steps. And the first step, just like with DevOps, first step was to bring development and operations together. Now let's bring databases together, and then let's automate that so we won't need to do it like manually or even approve the changes at all will be deployed automatically. That is something that will be slightly harder and will take longer, in my opinion.
I have a second question. I like the idea of DevOps. I apply in my daily basis. But what I see when I'm working full front-end developers, back-end developers, only developers, is a resistance to include the DevOps SRE concepts and supposing they work. They have huge resistance. How do you see that to apply the left shift and everything that you say? That's amazing. Is that
the biggest issue I see here, and it was cutting, the internet was cutting, so I didn't get full question, but I will still try to answer. The biggest issue that breaks our reasoning about that is obviously the context switch, right? Developers will not be happy to go to some yet another system to do this left shift. They won't be happy to receive an email showing them that, hey, something is not right or whatever. What we need to do is we need to integrate those things into their environments as much as possible. So just like when they are using Visual Studio Code, IntelliJ or whatever, if there is a performance issue, it should pop up right there, not somewhere else, not yet another system. It should pop up there. Similarly, when they have code reviews, if there are problems, we ideally should show those issues inside the solutions they use for code reviews. So this is the first step to basically integrate with what they have now and just let them use it. And overall, I think developers will figure out how to make it better because they are very good at tuning and optimizing their environment. So they will figure out how to, put those pieces around so they are super comfy for them and convenient to use. But the very first thing is, if we don't do that inside their environments, but expect them, hey, there is this yet another shiny system you need to use, they will be hesitant to do so. We need to integrate into what they have now to make the transition straightforward.
Yeah, nice. Yeah, that's a very insightful thought. Yeah, makes sense. Thank you.
Cool. Thank you so